Well, hello there. My name is AG363 and welcome to my methodology video. Before we get started, this video will be presented with my avatar with the following slides and pictures to the topic. The topic of the video is the pesticidal properties of seaweed on mollusks. Anyways, before we truly start, fair warning. If you have molluscophobia or lepidopterophobia, which I severely doubt, please take note as there will be some pictures of these creatures in the video. Now back to the video. Mollusks, which is the name for snails and slugs, are pests in that they eat bok choy, also known as Chinese cabbage, with their scientific name being Brassica chinensis, is a leafy green vegetable with broad, thick, tender leaves, and heavy midrib, and is used for food consumption for its mild flavor. It can be harvested at early stages for salads and later mature stages for cooking stir-fry, soup, or braised foods. They have a time span of 6 to 7 weeks from planting to harvest and can either be grown in either a pot or container or a plot of land. In terms of care, the soil should be evenly moist for them to grow fast and stay tender. Should be monitored for further care. Snails and slugs are two of the most common pests for Chinese cabbage. They both have the scientific name Gastropoda and are part of the phylum Mollusca. There are 3 types of Gastropoda, which are those with shells, snails, which have their soft body parts withdrawn completely into their shells. Those without shells, slugs, and semi-slugs, which do not withdraw their soft body parts completely into. They damage the cabbage by eating their leafy parts or just eating the whole plant altogether. They are also carriers of the parasitic worm, rat lungworm, with their scientific name being Angiostrongylus cantonensis, found in rats. There are some cultures that partake in the consumption of snails and slugs. These people have the chance of contracting this parasite through this method or for consuming cabbages with infected snails and slugs on it, as infected rats pass larvae of the parasite in their feces. Snails and slugs get infected by ingesting the larvae, and these larvae mature in snails and slugs but do not become adult worms. The life cycle is completed when rats eat infected slugs or snails, and the larvae further matures to become adult worms. For this research, the pest management that would be conducted would be using seaweed as a chemical control. The seaweed, specifically sargassum seaweed, from the family Sargassum, is a brown algae that has many leaf appendages, branches, and round, berry-like structures that make up the plant. These berries are actually gas-filled structures called pneumatocysts, which are filled mostly with oxygen. Pneumatocysts add buoyancy to the plant structure and allow it to float on the surface. Aside from its physical description, we are interested in whether its salt content, salinity, from the ocean would be effective against snails and slugs since salt dehydrates them and essentially kills them. The seaweed would be collected from nearby beaches and would be placed in the surrounding plot as a barrier before planting. After 3 or 4 weeks from planting, more seaweed would be spread between rows of the cabbage for the effect of pesticide and fertilizer. Sargassum seaweeds are tropical and subtropical brown macroalgae of shallow marine meadows. These are nutritious and rich source of bioactive compounds such as vitamins, carotenoids, dietary fibers, proteins, and minerals. Also, many biologically active compounds like terpenoids, flavonoids, sterols, sulfated polysaccharides, polyphenols, sargaquinoic acids, sargacrominol, thiophytine were also isolated from different sargassum species. These isolated compounds exhibit diverse biological activities like analgesic, anti-inflammatory, antioxidant, neuroprotective, antimicrobial, anti-tumor, fibrinolytic, immune modulatory, anticoagulant, hepatoprotective, antiviral activities, and so on and so forth. Hence, sargassum species have great potential to be used also in pharmaceutical and nutraceutical areas. My hypothesis is whether the seaweed salinity is an effective pesticide for Chinese cabbage against snails and slugs. My objectives are to firstly attain the quality yield during harvesting time. Secondly, determining the seaweed's effects on the yield. And thirdly, determining the seaweed's effects on snails and slugs population. With these 3 objectives, let's see if I have managed to complete them during the following research. The selected land must have weeds and rocks or stones removed, as they cause competition of resources and prevents proper root growth respectively for the Chinese cabbages. Afterwards, the land has to be measured in order to calculate the space needed for the cabbages and the seaweed. This is used for good soil conditions such as soil texture, pore space, soil nutrients, and so on. It also attracts good soil bacteria due to the lactic acid production, which is beneficial in breaking down soil nutrients for availability of the plants. Mix into soil and leave it for 1 week before transplanting. The next step, which is step 3, is transplanting. When transplanting, make sure to water the seedling tray and soil bed so as to prevent the plant from dying of transplant shock. Transplant shock is when the plant is being displaced from its original position in the soil and is realizing that it has been moved to a different location. This displacement causes the plant to immediately react by realizing that it is losing its original nutrients, soil condition, and water supply. The next step is obtaining our seaweed control. I placed the seaweed in the trench created around the soil bed and made sure that the leftover seaweed placed in between the row did not touch the seedlings. This is because I feared that the salinity would affect the plant negatively and cause them to die from increase of salinity. Also, I noticed that the seaweeds were slowly being broken down into the soil 2 weeks in, and so I went for a second round of seaweed collection, which was funny because when we got there was no seaweed to be found. This is because the night before, there was a strong wind, which was near similar to a cyclone, blowing in that night, and it might have also blown away my seaweeds further out into the ocean. I took note of this fact that external factors such as wind and waves are involved in the availability of seaweed, so I had to wait for the next week in order for me to get the right amount of seaweed needed to last for the next 2 weeks for my cabbage soil bed. Step 5 is plant care management. For me, this was checking whether there was any signs or symptoms of pests and diseases of the growing seedlings, watering them every morning and evening, and weed control by hand. These activities were to ensure that the cabbages were growing without any harm done to them. Of course, the pest did not come until later on nearing the harvesting period, but it was not the pest that I was expecting. The last step, which is harvesting time, and OMG, what a period, because I noticed a symptom and I saw the signs, and by God, this was not the pest that I anticipated for. While there were healthy cabbages that were immediately harvested, the ones that were damaged had a little surprise in the center of its leaves. It was small, green caterpillars. These little guys caused damage to the baby leaves growing in the center of the cabbage, and the larger outward leaves were also affected. After killing those on site, the affected cabbages were able to grow healthily again given early intervention and more recovery time, which were then harvested later on. Unfortunately, many cabbages were still affected by this pest, which I believe was due to how close spaced the cabbages were, making all the cabbages surrounding the damaged ones easily susceptible to the caterpillars. Now, onto our conclusion. To conclude the following methodology video, each manner of practical application to the growth of the cabbages, together with the chemical control, were able to complete each of my objectives. Sort of. For the first objective, I was able to obtain the optimum quality yield in the cabbages that were unaffected by pests and diseases. My second objective was the ability to observe the effect of seaweeds on Chinese cabbages. And I have to say, that seaweed, being a fertilizer, is not a joke with how big my cabbages grew, and that the damages only occurred near the harvesting period due to the unavailability of seaweed in that time frame. I'm also sure that the seaweed was responsible for there being no signs or symptoms of pests or diseases during the early stages of the cabbage's growth, not only because of its salinity, but also because of the ocean smell it was permitting. Now, I would like to give credit where credit is due. After all, without these people, I would never have done this video without them. I would like to thank my mom for transportation, my brother for a helping hand during plant care management, and my sister for editing and putting this video together for me. I wouldn't have gotten so far without you guys. Thanks for watching my video, and have a great day. 发发再见 lava, 就发水福。